Okay, the purpose of this lesson is to just build on the work that we started last lesson on direct proportion, but this time we're sort of bringing that factor of ratio and also trying to move that into a practical setting. Remember that, we just touched on it last lesson, but a ratio is just the relationship between two things. Now, if that ratio is consistent or it's the same, then we can say that something is directly proportional, or it has a direct relationship. So that's what we're looking for, and we did a little bit of that last lesson when we graphed the straight lines, that if it was straight, then it was directly proportional. If there was a wobble or if it curved, then we'd say that there isn't a direct relationship. Now, the formula that we're going to use for this is y equals k times x. Now, essentially, we have variable, which is just something that changes. We've got another variable there. So there's our relationship between two things. We use the term k to represent the ratio. Sometimes it's called the rate. Okay. Now, the other thing I'd like you to notice here is just how closely this looks like y equals mx plus b. Now, if we take off the b, we're left with y equals mx. What did m represent when we did it previously? Oops. Oh my goodness. Okay, it represented the gradient. Now, that means that if we come back up here and look at this k, it is the rate or the ratio. But remember, when we're graphing these straight lines, when the rate increased, the steepness of the slope also increased. So this really is building on previous learning that we've done when we've been doing that coordinate geometry, where we've been graphing gradients and looking at the steepness of slopes and so on. Okay, so y equals kx is absolutely a key formula that we're going to need. Okay. Okay, so let's look at a practical example. The height to weight ratio in adult males is 2.26. Okay, now height to weight ratio. Notice that height is first and weight is second when we set it like this. Okay, is 2.26. So what this would indicate is that this is our ratio. This is what indicates the relationship between height and weight. So the question is, what is the height of a 70-year-old male, knowing that 2.26 indicates the relationship? So y equals kx. Now, if y is the subject of this equation and it's written height to weight, then what we're going to say is that y is equal to the height. Now, k is our ratio, so I can actually put that in. And we do not know what the weight is, but we're going to make that equal to x. Now, because the question says the height of a 70 kilo, sorry, I've muddled that a bit. So we do actually know what the weight is, 70 kilos. But this formula that I've written here, is how we'd set it up before we knew anything. Okay, so what we can now do is substitute in the bits we do know, which is just that extra bit about the weight times 70. And we're actually left with just quite a simple calculation here. So if I then calculate the height, which is just a straight calculation, I could get 158.2 centimetres, and I've therefore used the 2.26 ratio to determine what the height of this person is. So if we think about this further, if it was the height of a 75 kilogram person, we could still work out how high they are. Now clearly we're generalizing here, not all body shapes are the same, but it's using it as a bit of a predictor. And we're looking at averages across a whole range of population, okay? So I guess that's the first simpler application of what we're doing with y equals kx. Now, if we extend this further, we're going to use the other variable. Now, the question said height to weight ratio. So we still set this up the same way. Okay. But we know what the height is. Now we're left with the same algebra that hopefully I've drummed into you guys, is that we just need to rearrange this to make weight the subject. So when we have a multiplication, this is exactly the same as if I had, 7 equals 2x. To make x by itself, I divide both sides by 2, okay? So that's what we're looking at here. So it's exactly the same as before. So this then becomes 180 divided by 2.26 equals the weight. And if I jump down a little bit further, I can then get that the weight is equal to 79.6 kilograms equals weight. So that's, I guess, the first application of looking at y equals kx. Okay, so for the next one, a factory employs two types of workers: apprentices at $5.50 per hour and experienced workers for $12.25 per hour. So we've got two different workers and we've got two different rates of pay. Okay, so maybe the first thing to make a note of here is that we're probably going to be looking at two separate y equals k times x equations. Okay, so just don't get confused with them thinking that these are going to be intertwined until a bit later on. Okay, manager employs 3 experienced workers now. How many apprentices could be employed instead for the same amount of money? Okay, now as I just said, don't get confused. We can bring them together in a minute, but we can do that later. Y equals kx. Now, if we are looking at, so this is for apprentices, what's the rate? I think the k bit's the easiest bit, because we can identify that if you get paid $5.50 an hour, if you work 10 hours, it's still $5.50 an hour. If it's 20 hours, $5.50 an hour. That's the thing that's staying the same. That's our constant. Now, y is the total cost or the total pay that somebody would receive, and this is how many hours they worked. Okay, so the total cost for employing somebody is $5.50 multiplied by the number of hours. Now, it's the same over the other side, where the total cost for an experienced employee, it's the same calculation, but it's a different rate. They're getting paid more because they're more experienced and in theory they're more valuable to the company. Now the question says, employs 3 experienced workers now. How much could the company employ? They employ 3 experienced workers now. How many apprentices could they employ for the same amount? And because I'm a bit of an idiot, apprentices work 30 hours a week, and experienced work 40 hours a week. Apologies, I left that out of the question. So the question is, if the company currently employs 3 experienced workers for 40 hours a week, how many apprentices could they employ for the same money? Sorry, that was a bit disjointed. But this does give us a variable that we can start working with. So what we know is that there's 3 experienced workers. So the total cost for one of these workers is a straight calculation like that. Okay? Now, that equals 490. So each experienced worker gets paid $490. So this is for total for one experienced employee. For 3 employees, it's 490 times 3, which equals 1470. Okay? So $1,470 is how much, I suppose, this company can afford to spend on wages. But what that gives us on the other side is it actually gives us one of the variables over here, because I can now say, well, how many apprentices can we employ for the same amount of time? Now, how many hours is the answer it'll get? Again, how do we work this one out? I'm hoping that you guys can remember how to do this bit. Will tell us how many hours there are. This will say that the number of hours is 267.27 hours. How many hours does an apprentice work? Well, we'd need to then divide this answer by 30, and our answer is 8.9 employees, but can they actually afford 9? Normally, I suppose we would round this up, but they actually can't afford 9. They can actually only employ 8 and almost a ninth. So our final answer here would be they can employ 8 apprentices for the same money as 3 experienced workers. Okay, 8B on page 283, A3, is the work associated with this, with direct proportion. Can you start working through some of those questions, please?